Today I'll be teaching you two parts. Part 1 will be a diagram of a calorimetry setup, and Part 2, I will teach you how to solve for delta H over mole when a hot metal is added to water. For the calorimetry setup, you will need 2 styrofoam cups stacked together with water, a lid, which will hold a stirring rod, and a thermometer. Now the thermometer and the stirring rod can go through the holes of the lid. For an example question, in an experiment, 1.2 grams of sodium hydroxide is dissolved in 100 milliliters of water at 25 degrees Celsius. The temperature of the water rose to 27.5 degrees Celsius, and we will be calculating delta H in joules. Step 1 is to calculate the heat released, or Q, in joules using the equation Q equals mass times specific heat times change in temperature. Now the mass and specific heat is of the water, and the change in temperature is of the solution. So to solve Q, you will have mass of H2O, which is 100 grams, C, which is specific heat of the water, which is 4.184, and T of F, which is final temperature, minus T of I, which is initial temperature. And in this case, it's 27.5 degrees Celsius is the final, and 25 degrees Celsius is the initial. When you multiply it all together, you have 1,046 joules. Step 2 is to calculate the moles of a solute. In this case is sodium hydroxide. Now to do this, to find the moles, you take mass over the molar mass. The mass of this sodium hydroxide is 1.2 grams, and the molar mass of sodium hydroxide is 39.998 grams over moles. Now 1.2 over 39.998 is 0.030 moles. Step 3 of this process is to calculate the enthalpy change, or delta H, in kilojoules of moles to the power of -1 of the solute. To do this, you do delta H over negative Q, which we found was 1,046 joules, over 1,000 divided by N of the solute. And that is 0.030 moles. Now when we do this equation, it comes out as negative 35 kilojoules moles to the power of -1. Delta H is negative because the reaction is exothermic. The energy is released, causing the temperature of the solution to increase. So in the example of our coffee cup calorimeter, if we were to add a hot metal, stir it, record the initial and final temperature, we would use this process as to find delta H.